Hello, welcome to A-Level Physics Help. We're going to be mainly looking at AQA, however, remember this is applicable to all exam boards, so you can go from Edexcel all the way to OCR or whatever you want, okay? This will be applicable for all. In today's video, I'm going to be looking at radioactive decay. Okay, so this is quite an easy topic actually. You should all remember it from your GCSEs. There's three types. You have three types of decay, okay? You got alpha, so that is an alpha symbol as well. You have alpha, you have beta, that is again a beta symbol. And of course you have gamma, which conveniently that is also a gamma symbol. So we have alpha, beta, and gamma. So let's start off with alpha decay, okay? So number one is alpha. Now, alpha radiation consists of these things called alpha particles. So they look like this. It is 2 protons and 2 neutrons. They have a charge obviously of +2, which would be 3.2 times 10 to the minus 19 coulombs, and they have a mass of 4 multiplied by 1.67 times 10 to the minus 27 kilograms. So that's the mass and the charge of them. So what happens for an alpha particle? So we have right like this as well. This is how you do it in your decay. And basically what happens is you have a very, very unstable thing like this, massive, absolutely massive, okay? So a few protons in there, okay? And what happens is it just shoots off an alpha particle. So it shoots off one of these things with the 2 positives. You get that. And there is also a lot going on here. So your alpha decay happens when an unstable nucleus of an element X emits the alpha particle. The nucleon number obviously will decrease. So the initial, if we have, let's say 120 and 47, and we have X, it will go to 116, 45X plus alpha 4 and 2. So that's your alpha decay. Now your beta decay is a little bit different. You get beta minus and beta positive, okay? And basically it's just a proton becoming a neutron or a neutron becoming a proton, okay? And that can be written very nicely. So you get a beta particle, which is the normal one, and it's normally written like that because its charge is equal and opposite that of a proton, but its mass is much less than that of a proton. So I suppose you could also consider it an electron. And what actually happens is we have a z of x, and that becomes a z plus 1 of y plus 0 minus 1, your beta particle, plus this thing called an anti-neutrino. Okay, so these we will cover in hopefully a few videos time, but for now just know that they exist, and you need to know about them. I believe they're covered in topic 1.4. We're only on 1.2 right now, okay? So what's actually happened here is you've gained a proton, okay, and the negative charge has left, okay? And then gamma radiation is probably something you're all very familiar with. And basically, when there's too much energy, it just emits a photon. So the atom emits a photon like that. Okay, so you need to know the ranges for them. So ranges, gamma, can go through thick metal. Beta is not as strong, so maybe sort of a thin sheet of metal will stop it. And there are specific types of metal which they like you to know which can cover it, so it's important to know that just maybe a thin sheet. And alpha can pretty much be stopped by maybe a bit of paper or something quite weak. So it's important to know that obviously this has the highest penetration, this has the middle penetration, and this one has the lowest penetration. So yeah, hopefully you guys found this useful. It's very basic, just like your GCSEs, and hopefully you guys can do some practice questions on this. It's relatively simple. The important bit is just to know these equations here. So you need to know this equation and obviously this equation. Both are very simple decays. Hope this is helpful, and I'll see you all in the next video.